I appear to be live. That's wonderful. Little photo bomb thing going on here. Guys, well, it looks like we have the usual suspects here, pretty much. I think a lot of people watch this via video, but guys, now let me man the clicker. My presentation today, guys, and this is going to be a surprise to everybody, is actually going to be somewhat positive. Wow. Normally it's gloom, doom, and despair. Okay, that's normally what we do. Today it's going to be positive. It's how to avoid problems when you're dealing with LVT, LVP, and the rigid core products. Now, basically, let me say up front that in no shape, fashion, form, or imagination is this presentation intended to promote any product or group of products, or to criticize or torpedo any group of products or individual product. I have to say that, or I get a phone call from Dewey, Cheatham, and Howe, and says, "You've slandered my client." So we have to be careful, don't we, George, about what we say. Now, guys, that picture was taken in 1907, by the way, but let's just do a brief history of LVT and LVP products and also the rigid core. I was a little surprised that the products actually began to exist, and they were really vinyl planks then. They were resilient sheet goods that somebody spent $50,000 for a Schoen cutter and cut it up into planks, trying to simulate wood. And that basically has been going on since the mid-'70s. I didn't really realize that. I hadn't really become aware of it until fairly recently. Now, apparently the intent was to increase the realism, which means they're trying to imitate wood and they're trying to get better at it. But most of the products there, guys, and for pretty much the years to come, up until about 2000, were peel and stick type situations, do-it-yourself type situations, not really huge influences in the marketplace. Now, in the early 2000s, a couple of things happened. Number one, it became possible because of the way the product had evolved. It was no longer just an unbacked material or peel and stick. There were layers of product, and it was a viable product to be glued directly to the floor. And also, and I think this is probably the most important, is there were several leaps in the technology involved to create what the product calls the decor. In other words, that's the printed vinyl film that gives you the visual that LVT presents, and LVP, and likewise the solid core products. Now, those situations, guys, it's not just two-dimensional visuals, you can get textural visuals. Well, somewhere about this time, people begin to look at it and say, "I really like that." And the market started surging, really exponential, explosive growth. Now, what happens when you get explosive growth in a product? Everybody wants a piece of the pie. So basically the manufacturers, and not just the ones in the US, worldwide, started making this product. Now the fact remains, guys, that very few LVT and LVP products and solid core products are actually produced in the US. We had presentations from Engineered Floors. They get a lot of their product from different places, not necessarily China, but they make it work because they figured out how to do it. Mohawk, I think, said that they're going to have over 50% very soon will be actually manufactured in the US. I don't have any verification of that, but I think that's a good thing. The fact is that Mr. Donnelly here wrote a wonderful white paper back in 2019 on LVT and LVP. And at that point in time, we looked up madeinchina.com. And at that point, 336 or 35 individual entities in China were producing LVT and LVP. I think today the total is well over 400. I don't know about you guys, but that gets certain portions of my anatomy kind of quiggly when I think about that is a little bit scary, but if you do it right, if you do it right, it can still work. Now, I kind of feel like that I was, I guess against my will transported to that magic LVT city, okay? And like most cities, LVT city has good neighborhoods, really good neighborhoods, and really bad neighborhoods. And as Lou said, since we live in the sewer at the drain of the industry, basically, guess which neighborhoods I get invited to? The only very, very poor ones. Now, it seems like in the past 18 months or so, I've basically been immersed in LVT. That's why I say I moved to LVT City. I have about 15 projects going on, and these are unique to me. After I had projects with very big construction concerns, I'll leave it to you to figure out who that is, okay? They basically had problems with LVT, and I'm not talking about 100 square feet. Now you're missing 2 or 3 zeros. 400,000 square feet, 250,000 square feet that were failing, and guess what that does? It's failing. I went to the job site, did my report, did my analysis, figured out what was going on, submitted it, and then they go back to who they bought it from. Remember that, who they bought it from, basically to get support. And what do you think happened? Wasn't any, basically. Everybody know what a warranty is? A warranty is a piece of paper that gives you the world in the first paragraph and takes away the world plus 35% in the next 2 paragraphs. And a warranty is only as good as the audited financial statement of the person who supposedly is supporting that warranty or servicing it. Well, this turned out you can't get with these manufacturers coming from China, not necessarily bad, but good luck at finding out who it actually is. Or good luck at finding out, show me the money. Where is the money if you have a problem? These things are, when you're talking about 450,000 square feet of LVT and about 275 units and all the labor involved in replacing that. As Everett Dirksen said, you talk about $1 billion over here and $1 billion over there. After a while, you're talking about some real money. and that's the truth. Of course, I guess now it's trillions, isn't it? The billions don't really cut it anymore. It's got to be a trillion. I don't think anybody really even knows how much that is. But nonetheless, this is what kind of moved me into this. What they did was these large construction firms basically commissioned me, and I think this is fantastic. They commissioned me to start looking at their projects from the time the specs are issued. In other words, I can look at Division 3, I can look at Division 9, and this is months and months and sometimes years before it comes out of the ground and you're actually going to need to put anything on the floor. Proactive stuff. What a concept, man. So basically to look at this, I get to look at all the Division 3 stuff, find out if they're trying to sneak in some kind of crazy admixture into concrete, what the mix is going to be, what the vapor retarder is going to be, all that stuff, so I can stop it when it can still be stopped. Once you get the slab placed and there's not the right thing underneath it, it's a little late. You can't do much about that. And basically looking at the LVT or LVP or the rigid core stuff also as a product and saying whether or not I agree with the specifications of the product and give them specific due diligence things to do before they start the installation. And that's really what it comes to, guys. If you buy a product from somebody and you can't get back to the person who's ultimately responsible, nothing good comes of that. Okay, of LVP and LVT, and specifically, do not have an applicable ASTM standard by which they are manufactured and judged. And they claim they do, but if you look at it, both the 1066 and the 1700 are a series of tests that need to be performed, and there are construction criteria and performance criteria that are simply not met. Even, interestingly enough now, the solid core stuff does have an ASTM spec. Interesting, 3261. As Casey Stengel said, you can look it up. Of course, it's going to cost you $75, but that's all right. The spec for the rigid core And I'm a voting member of ASTM, but I don't remember getting a chance to vote on this because it allows 2 millimeters. Everybody know what 2 millimeters is? I think some people think millimeters are the same as mils. A mil is 1/1000th of an inch. A millimeter is 0.0397 inches, a little over a 32nd. 2 millimeters, a little over a 16th, between a 16th and an 8th. Now, somebody needs to find me, and the ASTM 3261 allows that level of curl right out of the box. Whew. Somebody needs to find me about 1,000 customers that actually might have some probability of accepting that. I don't know of anybody that would. But just be aware of that. If you do rigid core, make sure that the people you're buying it from know that's a no-go. That is not going to fly. It's got to be flat. Flat, square, and stable. That's my 3 magic words with all kinds of modular flooring, whether it be carpet tile, LVT, rigid core, whatever. Now, without question, these problems I looked at are proof that they are widespread. Let me, by a show of hands, this is fairly brave. Anybody in here ever had a problem with an LVT installation? Boom. And there it is. I was kind of if nobody raised their hand, that would have been kind of bad. But everybody knows that the product is creating issues for you guys. And it's huge. Is it necessarily a bad product? Absolutely not. Absolutely not. And that's the purpose of this presentation today, is to try to wind your way through and figure out what are you getting and how's it going to perform. Now, main problems. We're going to go through these one at a time, like it says at the bottom. But environmentally produced and induced dimensional change, inherent dimensional and planar instability due to improper manufacturing and unbalanced manufacturing, plasticizer migration. And I promise I may have to do a little bit, but I'm not going to have a chemistry lesson today, okay? I've done that before, and Jeff gets the hook and comes to the stage and pulls me off. So I'm not going to do that. We've got installation-induced issues, inherent performance issues, which I call the permanent indentations that pass the test but still look bad, basically, and concrete moisture, our old friend, and alkalinity that lead to compromise of not only the adhesive but also the product itself. Now, I'm very confused always when I read LVT and LVP installation instructions. Here's some quotes from a couple of things. I love this. Post-installation temperature allowed is an ambient temperature of 32 degrees Fahrenheit to 100 degrees Fahrenheit. Hello? Okay, that's nice. Another guide says, and this says for non-heat controlled areas, but they're allowing you to place the stuff there. It goes from minus 25 degrees Fahrenheit to 155 degrees Fahrenheit. Yet in the next sentence, it says you can't put the stuff in direct sunlight. And you just can't have it both ways. And the point is, guys, always, 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 I don't care what the manufacturer says in their instructions, always acclimate the stuff to quote unquote service conditions. And that means the ambient temperature, ambient humidity that the product will live in when it's being used in its intended end use. So if you don't do that, that's number one blame game. Lou talked about playing the blame game. That finger's going to come right at you. If you don't hit it properly, ergo, it's your problem. Or there was a temperature change. Well, hello. One of these projects I went to had digital thermostats in the 250 units, and you could quit of them and know exactly what the temperature and humidity was every minute of every day since the thing was installed. Well, that put the old slam the jaws shut on the quote-unquote manufacturer. There was no manufacturer. It was a jobber or an agent or somebody who set up an office somewhere and cut a deal to import this stuff and sell it. Beware, beware. Always, always, no matter what the manufacturer says, acclimate. Don't let, one of the projects I'm working on, they said, I need something I can put in when the weather's terrible and I don't have HVAC. Said, well, you're barking up the wrong tree. If you do that, get ready to go to your wallet. That's all you can say. Don't let that happen to you. Now, this is the beautiful thing here. This is a job, wait for it, multifamily, of course. Most of the things I've been involved with right now are multifamily things, huge projects. This one was about 250,000 square feet, something like that. And this was basically every end-to-end joint had shrunk open about 1/4 inch, or 3/16, all right? But now, once we analyzed it and studied, it was a manufacturing issue with the curing of the vinyl and just some unbalanced tensions and what have you that were causing residual shrinkage. Now, here's a question for you. Look at that. And what do you think the manufacturer said was the thing to do to solve this problem? Grout it. Seriously. Can you imagine? I sat there and heard this guy say that. I said, come on. And it's somebody I knew who'd been in the tech service, part of the industry for a long time. I said, man, you can't be. That's never going to stabilize. It's going to continue to move. What are you going to do, come in every 6 months and grout 200,000 square feet? I don't think so. But that's the kind of response that you get if you don't have the right person that you have designated and you have told very clearly that they are responsible. And they didn't have that here, and there was no place to go. Now here's a situation. By the way, that's 12 business cards between the end-to-end joints, and that was basically every joint in about 85% of the building. This was the huge one, 450,000 square feet, and there was about 100,000 square feet, I think, that they had inspected. I didn't get to look at every bit of it, and said it was, quote, acceptable, okay? I looked at some of those units when I was there. I want them to tell me who it is that they thought was acceptable, because the gaps are only about half that big. So, but that's supposedly acceptable. So this is a real problem. These people, when a unit becomes vacant, they can't re-rent it, and they're getting no satisfaction from the people that they purchased it from. So that's a terrible situation. Now, let's talk about plasticizer migration. I know. Here comes the chemistry lesson, okay? Guys, just so you understand, I guess this derailment up in East Palestine, Illinois, which was vinyl chloride, which is one of the necessary precursors for making PVC, that kind of brought some new attention to the whole PVC issue. But hey, vinyl chloride is nasty stuff. There's no question about it. You have to react elemental chlorine with ethylene to get that vinyl chloride, and that is a necessary, you have to heat that thing up to a certain temperature to create the monomer that allows PVC to be made. You take the monomer, you polymerize it, and that gives you PVC. Now, just so you understand, plasticizer has to be mixed with the PVC, mixed, not bonded, mixed, basically mechanically incorporated into it. There's no covalent bonding between the plasticizer and the vinyl itself. It's simply a mixture. So the plasticizer is free to leave, and it does every single time, always, in every PVC, flexible PVC installation. Where you get into trouble is what's normal. I mean, you know there's some that's going to happen, but what's normal? And there's no data, frankly, to support that. But I know what's not normal. This particular job, you got to understand that the plasticizer being used today is a terephthalate. Here comes the chemistry again, I know. But basically, the plasticizers that have been used for years in vinyl back carpet tile are what's known as orthophthalates. Now, all ortho means is, now when you make something like a plasticizer, you're joining this stuff with this stuff, and you bring them together, and they bond through catalyst and heat and what have you. And it turns out that this part of it is what's called an aromatic ring in a plasticizer. That's it's like a hexagon, got 6 points. Those are carbon atoms. Oh, there's that carbon again. trouble, okay? Carbon atoms, if you join right there, that's ortho. But if you join here, that's the tera position, and that's a terephthalate, not an orthophthalate. Orthophthalates have been proven to be reproductively toxic. They cause mutations, and there are a lot of regulatory issues that you avoid by using the terephthalates. And so that's what's being used almost exclusively in LVT and LVP. That's the good news, I guess, to some extent. The bad news is that that particular material, that plasticizer, it's a good plasticizer, and even though they call it non-phthalate, it's still a plasticizer, it still migrates, and when it comes out and goes into whatever it's in contact with, it has the same nasty repercussions that the orthophthalates do. So it doesn't really change much, but the key is the terephthalates are less compatible with the PVC, and once you mix them together, you require higher fusion temperatures, longer oven dwell times. Those both equal money, by the way, to the manufacturer. Higher fusion temperatures, more power, more money, higher dwell times, throughput is affected, more money. So basically, it operates at the edge. And I suspect on this one right here that it never got cured properly. We took an adhesive scraping on this job, guys, and analyzed it and took an adhesive sample out of the pail from the job actually used. No plasticizer in the one out of the pail, as expected, but the total weight of that sample, 58% of it was plasticizer, the scraping sample. It was completely, not to use a Ghostbuster term, but the adhesive was slimed. I mean, badly so. But that really didn't have much to do with the shrinkage that you're seeing. That has to do with the plasticizer leaves the film. What does it do? It shrinks. Doesn't have a choice. And it's going to continue to shrink. This was another one that they kind of recommended grouting. Same folks. So you've got to be really careful about who you deal with. And we're going to get to that. The purpose of this whole thing, guys, is going to provide you with a bit of a checklist. And that's like the last slide, which Jeff is probably going to make me get to pretty fast here anyway. So give you a checklist to go through to make sure you dotted those I's and crossed those T's before you start a job. Now, this one was horrible. It's one of the worst things I've ever seen. Installation problems. Till God makes us all perfect, there are going to be installation problems. That's a door jamb. We've all had that. I've done it. You know, you get there, you didn't quite relieve it quite enough on the right side of it. You couldn't bring it in. You didn't pay attention to it. The good news about installation problems is, guys, most of the time they can be corrected with a little bit of labor and not a tremendous amount of money, but some. The real problems, guys, are what's known as latent or hidden defects. Lou talked about this a little bit yesterday. If something comes to you and you cannot detect what's wrong with it, and there is something wrong with it, by reasonable inspection, then the manufacturer, in my way of thinking, and also the lawyers, they're responsible for the material and the labor. None of this, we're going to give you some material and you put it in and pay for it. No, I agree with Lou on that. He had a comment on that was a little more colorful than but that's neither here nor there. So these things are fairly easy to handle, and the product is wonderful to install, and as long as it stays where you put it, it's okay. Okay, performance issues. This is I'm talking about back to the 970 and the 1914 tests, which are residual indentation and the static load test. Now what we've got here is some of these products can pass those tests and it still looks terrible. Doesn't take much of an indentation, just about a 64th of an inch with side light, and you see it. So that's something to be aware of. My main problem with that is when people try to put 2 millimeter LVT anywhere but on a absolute solid, non-deformable subfloor. This particular project here, they'd run 2 millimeter LVT on top of a 5 millimeter crumb rubber, crumb rubber acoustic enhancement underlayment. So let me say something just for a minute, because this came up on the Fuse network about, 3 weeks ago. Do not, NOT, not use crumb rubber underlayments under any PVC containing product. Even Lou and I worked on a couple of legal cases on this, and I think maybe had some impact on that. But do not do that. Even the manufacturer, Shaw, for instance, in their generic resilient flooring, not just LVT, resilient flooring instructions say, do not use those. So don't get caught in somebody selling you some crumb rubber to go under PVC. Chemically, they don't get along. And I had to bring that up because that was a very hot topic on the forum a few weeks ago. Now, to my opinion, you put 2 millimeter LVT on any kind of deformable underlayment, you got problems. You're going to have indentations. On that particular job, a bucket of adhesive sitting for 1 hour left a permanent circle. Never go away. So they wound up having to take it all out. Some of it they came in and put, this was a major manufacturer, they provided them the rigid core stuff and went on top of most of it. And it looked great and didn't mess up the transition. So that was a good solution to that problem. Now, our good friends, concrete, moisture, and alkalinity. In this particular case was one where this is usually a very, very good product, but the grading and drainage here was bad. The concrete was terrible. It was old, no vapor retarder. The whole shooting match, it literally enough moisture came up to get liquid water. It wet out the cork. They use a cork underlayment for acoustic enhancement. And I'm a big fan and a big, big recommender of, if you're going to have an acoustic underlayment, let the manufacturer put it on. Don't install it as a separate unit, another place to screw up and get in trouble. Let the manufacturer put it on. This actually softened the cork, swelled it, and caused all kinds of deformation in the product. So it had to go, and you had to come in, mitigate it, the whole suit and match. So not good. That you never want to see, never. This is your checklist, guys. This is number one with a bullet. Understand what entity is presenting the product for sale. Make no question. My idea of ideal situation is it's one of the big guys. Shaw, Mohawk, Milliken, Bentley, you name it. Engineered floors. Who's presenting the product for sale? Make no mistake. Make it extremely clear. Engage the manufacturer early in the process as possible. Make it extremely clear in writing that you expect them, not some mysterious place in China or South Korea or the Philippines or Vietnam, to be responsible for the quality and the warranty. They have the technical support and the financial resources to support your warranty. Make sure they understand that that's what you expect. Now, become familiar with and follow the manufacturer's installation instructions to the letter. No war equals. Use the labeled adhesive. I preached this sermon before here, but that's basically, why would you want to give them an excuse that you save 1 penny a yard, okay, by using somebody else's adhesive? Why would you want to give them an excuse to come in and point the finger at you didn't use the adhesive? That's what the problem is. It's not true, but guess what? It's going to cost you $100,000 to prove it. So why would you do that? And that's the only thing, if you'll notice, that's application related. Everything else is about the due diligence that you do beforehand. Now, make it a condition of sale. I did this hundreds of times while I was with Milliken. It would be required to make the sale that somebody from technical had to be on site for 1 day or 2 days or whatever. Never lost a job. If I'm there and it's not being done properly with the proper things, I'm gone. And likewise, you need to get that guy on site, a technical person. That's why you go with the major guys, because they have the resources. Get them on site, keep them there for at least a couple of thousand square feet. At least that much. That way you have a quality benchmark that locks in everybody. And you have some place to go if there's a problem downstream. You photograph it. You make them give you a report. If they're reluctant to give you a report of what they saw when they were there working with you, you send them an email. Just like the lawyer said yesterday. Send them an email that you liked everything, you saw nothing untoward, nothing that didn't meet your specifications. That is absolutely key. Now, if you don't get the written report, you give it to them. Guys, that's basically, you don't ever want to walk in and see this guy on the right. That's very unpleasant. It really is. Okay, that's what I got, guys. I appreciate your time. Any questions? Now we're going to do questions at the end, right? Okay.
No questions.
No questions. Thank you very much.
You've left us a half hour. Damn kids.
Did it again. Oh, my. Oh. Well,
Yeah.
they shouldn't have put me first.
No, that's okay. Some of these subjects, just so you know, there was a survey that was performed with you guys as to what you wanted to hear at this conference. And there were a whole list of things that were read to us, and Sim jumped on the LVT. There was a group, RH, pH, and curing compounds, which I said I'll take. And then I said, do I have 3 hours? And they said, no, you have 15 minutes. And I said, well, okay, we'll see what we can do. But we're going to try to quickly then talk about what's important, what can impact your ability to successfully install a floor covering, and of course we're going to talk about concrete floor slabs. So we're going to touch on new construction in situ RH, remodel in situ, new construction pH, remodel pH, curing compounds for new and remodel. And at the bottom, we've heard a lot of quotes that Jeff had, and I asked, they asked, well, add a quote of your own. So I added the one on the bottom. If it can hurt you, it likely will. So just take that with you. There is, and I'll recommend anybody that wants to learn more about in situ relative humidity testing. I wrote a white paper on this a number of years ago, updated it. It's on ResearchGate. It's also on my website. And the website is noted on there. The page is noted on there. And it really takes anybody who's doing testing in your office that you would like to see have a little more education, and or if you're using a third party, recommend they read it. Frankly, I think it's pretty good. It's about 10 pages long, but it starts in 1954 and takes you through why we did testing and who did studies on moisture in concrete, taking you up to current times. So I think it's a great background as to why you do things. And it's one thing to tell somebody how to do it. It's another if they learn why they're doing it, and it adds some impetus then, hopefully, to what they're doing. So, of course, we know in situ testing anymore is required or preferred by virtually everybody, but does it really mean what the reader is telling us? So if we look at new construction, if we've got a suspended concrete or a concrete over an ASTM E1745 vapor retarder placed directly under the concrete, that concrete should only get drier with time. So testing does become somewhat predictive. And I say should because there is the possibility that we're going to have a sprinkler blowout and anything that you tested is out the window the next day before you install a floor. But that 81.9% that you're looking at, should be a good reading, and it should indicate that the concrete is drying. However, if that slab on grade has an ineffective vapor retarder or the in situ data is now non-predictive, And on remodel, here again, just a quick piece of history, the in situ test has been used in Europe long before it was used here in the United States. And it came out of testing and work by Goran Hedenblad, who was at Lund University, and the test was originally intended and designed only for the purpose of monitoring the original drying of new concrete that was set on a vapor retarder and or drying from both sides. Period, the end. That is the only purpose that this test was intended to serve. We use it for remodel. We use it in a lot of ways that it was never intended to use, and that data then has to be recognized as potentially misleading if we don't have more data to go with it. So when we look at data such as this, 81.9%, on a remodel, on a building that's 8 or 10 or 12 years old, it really needs to be a screaming red flag that we cannot possibly have an effective vapor retarder under this slab. Concrete, given its own devices, should dry to the ambient or close to it. Bob Plan sitting there, I remember years ago, did some testing on an elevated deck on a project in Arizona because somebody was saying that carpet tiles failed because of moisture and alkali in a second story of a 30-year-old building. The testing was done, and the relative humidity in that concrete was about 35 or 40%. And I've done the same thing here in Arkansas. Well, not here, but in Arkansas. It will try to dry to that number. But again, if there is not a vapor retarder under the slab, whatever test data you are handed is worthless. It is not predictive. It should only be used as the reason to start a conversation with somebody about mitigation because there's not a vapor retarder. And the other thing I wanted to touch on is if you're having moisture testing done by third parties or even in-house, just make sure that you're getting all the data that you really need to document, to protect yourself. We want the moisture readings, whether it's in situ, calcium chloride, pH, or impedance, whatever has been done. We need both that data and the temperature of the in situ probe reading, okay? I get calls a lot of times and they'll say, well, here's my in situ readings, and I'll say, okay, what was the temperature in the concrete? What was the ambient condition? They say, well, we don't know. Well, that's interesting, but that data is not something that we can work with. It's too potentially fraught with problems. But there's also a lot of people out there that flat do testing wrong. And this happens to be an outdoor pickleball court failure, and it was tested by an engineering company because they are on top of anybody like myself or Donato or Sim. So this is a calcium chloride test that's set outdoors on the pickleball court, and they found very high moisture. Why did they find very high moisture? Because the sun heated the air under that dome and created a low-pressure system that sucked moisture out of the concrete. It turned into dew point overnight, and it actually saturated the salt. So they claimed there was like 25 pounds of emission coming out of that pickleball court. So they didn't do it right. But you need to know that things are done correctly if you're going to use them as a predictive test and or as a forensic test. I did want to touch a little bit about pH. First of all, ASTM F710, which we've always said required pH, it is gone. There is no pH testing requirement in F710. So if you have a spec that says test pH per F710, unless it specifically gives a date like F710-11, which would refer to a specific document published in a specific year, if it just says 710, there is no pH testing. So just be aware of that. There is a work item at ASTM, which is now in the hands of COS. COS is the Committee on Standards that has to approve anything that individual subcommittees or product committees work on. And it will be based on a comparative change in pH. And that kind of made me crazy when it first was being worked on, because I said, what are you talking about? So basically, we want to note that all concrete has basic ingredients, and then note that alkali is a base in solution. So I think all three of us have said, and Jennifer and other people, if you don't have a moisture problem, you cannot have a pH problem, period, the end. If you have a moisture problem, you do have a pH problem, period, the end. And those two things follow each other, but without a solution, you can't have quote-unquote alkali. Now, what's kind of interesting in what we're going to be doing, and it taught me something, the standard requires dealing with reagent water. And I said, what the hell are you talking about, reagent water? So water can be lots of different things that I didn't realize. And the other thing that they wanted to write in there was that you, or your testing company, or your employee, would need to go to the site with a glass vial and test his water before he did any testing on the concrete. And I said, that makes no sense, so I did take a glass vial, a plastic cup, and a Dixie cup and put some water in it and found that it was all pH 7. So we got rid of the glass vial anyway. But then I had to understand the idea of reagent water and what could happen. So most times you're told to use distilled water and or deionized water. I use distilled water. And yes, if you buy a gallon of distilled water and open it up fresh and pH test it, it's pH 7. I didn't know until he taught me that if air gets into that container, which it did, the carbon dioxide in the air will react with that distilled water, creating a very mild carbonic acid. Carbonic acid? Carbonic acid. And the pH of that water will now be 5.8. Hence, we want to measure the change and comparative change in pH, because chances are the water that's being used has been sitting in a vial somewhere, probably some air in it, and it's actually not pH 7 as your starting point. And I found that with my own water with multiple different types of pH strips, that it was reading between 5 and 6. So one of the things that I learned, and just then to share, I'd get tests over the years and somebody'd say the pH was 6. And I'd say, well, they don't know what they're doing because it can't be a pH of 6. Concrete cannot be acidic. They can't. But what it really probably was telling me was he had used distilled water that had been subjected to that carbonic acid condition and was sitting on concrete that either had a curing compound or some other reason that the water never got into the cement. And yes, the 6 was legitimate. It was the water. So one of the things that I do think pH strips are useful for, and meters, and I've talked to a number of people that have called over the years and said, wow, you know, we have a failure and the pH is 9, and we had condensate under the floor when we took it up, and I said, well, what was the pH of the condensate? And they didn't test that. So I want to emphatically recommend that if you do go out on a site and you do see condensate under a floor covering that you pick up, pH test it, because often it will be 12 or 13. And the only way it could have gotten that hot is based on moisture coming out of the concrete. And the reason for saying that is very often we will clean up the concrete, let it dry, go back and do a pH test, and now the surface of that concrete is in fact only a pH 9 or 10. And we say, wow, that's really not enough to have done the damage to the adhesive that we saw. No, but the adhesive itself was saturated with a higher concentration, and it was pH 12 or 13. So otherwise, so I can give Donato some time, curing compounds, real briefly. If I have an opportunity, the ideal cure is still blanket curing. You're going to pour the concrete, finish the concrete, put a blanket over it, let the structural guy tell us whether it's 3, 5, or 7 days, pull the blanket off and let the concrete start to dry. A lot of people resist that and say, we can't do that, we're going to use a curing compound. So there are 2 ASTM standards for curing compounds, C309, C1315. Both are for liquid membrane curing compounds, liquid membrane forming curing compounds. At least in 309 specifically it says silicates, which are sodium, potassium, or lithium, are reactive penetrants and not covered by the standard. So again, if we now start looking at, well, what are the choices and what do we want to look at if we have an opportunity to talk to somebody going into this? Again, the blanket cure is ideal. Second choice is an ASTM C309 compound that is dissipative. That is not part of the ASTM standard. It doesn't have to be dissipative to meet the standard. It can be non-dissipative. Non-dissipative means you will absolutely have to grind it off or sand it off before you can install a floor covering. Dissipative hopefully is going to break down under UV or under trafficking. You still may have a little bit of work to do. Chances are you'll get rid of it just by the light sanding you might do on the front end anyway. But if it's non-dissipative, again, you're going to have to mechanically remove it. And anything that's a reactive penetrant, that is typically the silicates that are our potential bond breakers, and we want to avoid them any chance we have. Okay? So, I only took 15 minutes. I'm going to turn it over to Donato so that we can hopefully open it for questions before we're all done.
All right. Thank you, George. So I'll try to get through this fairly quick. I got kind of a simple message here, similar to what Sim had to say. First of all, I'm Donato Pompo. I'm the owner of Ceramic Tile and Stone Consultants. And what we do forensic investigations for tile and stone all over the country and in Canada and other places at times. We also do a lot of quality control work where we go in and we write architectural specifications, procedures, and we'll go on job sites and we'll train installers and we'll perform a quality control process that I'm going to talk about in order to make sure things are done correctly. The specifications are followed correctly, manufacturer's directions. Also, we do a lot of laboratory testing as well and field testing for quality assurance that I'll touch on a little bit. We also own the University of Ceramic Tile and Stone, where we provide online training courses for the tile and stone industry, from technical and sales training courses to installation courses, on a course on how to write architectural specifications for tile and stone. So the agenda today is wanted to get the message out that construction defect litigation is not only doing well, it's thriving, unfortunately. I mean, our business is very busy, and there seems to be lots of problems out there. Construction defect is a big deal out there, very expensive, and you want to do whatever you can to avoid it. So I'm going to talk about how to avoid costly problems and delays. I'm going to talk about what is quality assurance, what is quality control, and talk about the old-fashioned on-the-job training that never ends. It's when I got into the industry in the union as an installer, things were done completely different than they are done today, and that's part of the problem why we do have problems. And, of course, I'm always going to talk about continued education. Just like doctors, lawyers, accountants, you need to have that continued education to stay on top of your game. So there's no shortage of defective work and failed projects. When there is a failure, it doesn't matter who's at fault. Everybody loses. Whether it's your time, because even if it's not your fault, you didn't have anything to do with it, but it's going to cost you the time to have to prove it. You might have to hire an attorney to defend you. It's going to cost you money, and it might even cost your reputation, even if it's not your fault. So whatever you can do to avoid a problem, regardless of whose fault it is, it's in your best interest. Just like driving, you got to drive defensively. Well, you got to work defensively as well. It seems that about 95% of the time when there is a failure, it is partially due to installer. I mean, unlike the other products that Sim was talking about, ceramic tile is fairly stable material. I mean, it can have problems. You can have excessive warpage. You can have some different issues, but it's not very likely and not very common. Installation products, they can have problems there too, but not very often. But generally speaking, as I pointed out up above, that when there's a problem, it's never due to one single deficiency. It's normally due to multiple compounding deficiencies, which I'm going to point out in the presentation. So when there are deficiencies, some of those that can be is the architect. I mean, we know that architectural specifications tend to be ambiguous and incomplete. They can also make design errors. We do quite a few of exterior veneer, or actually exterior deck installations all over the country. We just did one yesterday in Florida. We're doing one in Beverly Hills today, where you have, whether it's natural stone or ceramic tile, and you've got bad efflorescence, and other issues of debonding, and the efflorescence and the debonding is a symptom of the problem. The problem is how it was installed and maybe how it was designed by the architect. I mean, as an installer, you're not engineers, you're just following the specifications, and sometimes those specifications are incomplete and lead to problems. What about the general contractor? What's his job? He's got oversight responsibility. He's supposed to orchestrate things, but he also has the responsibility to vet the subcontractors and oversee their work to make sure they're being done per the specification. So they have responsibility. And so it's never just the installer. How can we limit installer errors? I mean, installers don't make mistakes intentionally. You know, generally speaking, the problems are due to the installer's lack of knowledge, pressures to be more productive, you know, get that job done, the general contractor pushing you, getting you on the job at the last minute, management pushing to reduce costs, be more productive. But one of the main things is inadequate supervision. You know, we do projects all over the country, and quite often we see where they just throw people on jobs. We did a quality control job. We did an investigation in Texas on this shopping center. They had failures. We tested it. We figured out what was wrong and came up with a specification on how to repair. And we were actually there full-time to oversee the work. But the labor, we had to train them. And then the full-time supervisor on the job, he would actually only be there for an hour or so, and then he'd take off to some other job. And then the next day, we'd have a different set of guys there. So it was a real challenge keeping everybody up to speed on what to do and make sure it was being done correctly. So lack of supervision is a big issue, because that's how we used to learn historically. When I was an installer, on big jobs, you had a foreman, a non-working foreman who was going around watching what everybody was doing, orchestrating things, and telling you, you know, do it this way, don't do it that way. And that's how you learned. That's how you became, you know, skilled in that profession. It's kind of a teamwork. And then when you were on smaller jobs, it was the main installer who would oversee the work of the helpers and the other installers to make sure things were being done correctly. And unfortunately, in today's world, we don't see that much. So here's a case study I wanted to share with you just to get an idea, you know, about the idea that when there's a problem, it's never due to one single deficiency, but rather to multiple compounding deficiencies. So this was a museum with a porcelain tile floor that had cracks. The tile assembly was on grade, concrete slab with crack isolation membrane. The problems were lack of thin-set contact. Per industry standards for tile and stone, you're supposed to have continuous contact, either 80% for residential floors or 95% for exterior or wet areas in commercial applications. That means continuous contact from the substrate to the tile. You can't have a void more than 2 square inches. That's the size of a golf ball. And all edges and corners are supposed to be fully supported, because those are the most vulnerable areas that can crack. So lack of thin set, tile wasn't beat in correctly. And this is a big deal that we see today, because there's such a big emphasis on tile lippage, about having too much lippage. What we find is the installers are not beating the tiles in, because if they beat the tile in and they didn't have enough thin set, now they got to pull it out and add some more thin set. So to avoid doing that, they'll gently embed it. So they're making an embedment, but they're not beating it in to make sure you have adequate contact. Wrong crack isolation membrane, wasn't suitable for what the conditions were, and it was installed over control joints. Industry standard says according to TCNA EJ 171, wherever there's an expansion joint or control joint in the substrate, it should be honored and continued all the way through. Now, there are some crack isolation membrane manufacturers out there that say that you can put their membrane over control joints as long as you add movement joints in the tile above, but it has limitations. And in this case, the crack isolation membrane didn't meet those limitations, and no movement joints. You know, we just did an investigation a week ago in Tucson, Arizona, a house that was in place, high-end residence. It was, I think, about 12 years old, 12 by 24, 2 centimeter, that's 3/4 inch, limestone. Literally, that limestone on the floor was sitting up a good 2 inches. It was peaked up because they didn't have any movement joints at the perimeters. They didn't have any movement joints within the field of tile. And we know that whether it's tile or stone, as it heats up, it expands. When it cools, it contracts. When it's subjected to moisture, it expands. When it dries, it contracts. And so these tiles go through a cycle of wet and dry, expansion, contraction. And so over all these years, eventually, the straw that broke the camel's back, it finally gave loose. And of course, it's only as good as its bond. In this case, it was installed over scribing felt, which was done way back when, which really isn't a legitimate material to bond to. So all those conditions add to it. So let's look at this. So on this one, we see that they had a crack in the tile. And you can kind of see the crack going into the thin set above it. Note this. Here's this condition here. Now you'd think, well, gee, he's got quite a bit of thin set there, but look at it. He crisscrossed it. So the continuous bond from the substrate to the tile is only at that intersection. That's the only place that it's continuous. So at first you'd say, well, he's got about 50% contact or so, but actually it's only about 25%. So that means it only has 25% of the potential bond strength that it should have. So here we go, and there, look at this control joint there. That's not a 1/8 inch control joint, which is what the manufacturer of the crack isolation membrane say. You can't go over more than a 1/8 of an inch crack. So that was too much, and notice the crack. The control joint lines up right with the crack of the tile. And this is just showing that they had control joints going in both directions here throughout this whole floor, and that's why that became such a problem. So again, combination of deficiencies that led to that problem. So what should have they done? For one thing is they should have gotten better thin set contact. Now at first, if you look at this photo here, this is actually a job that we just finished up in Kauai, Hawaii. It's a Hindu temple. They've been constructing it by hand for 25 years. We wrote the specification. We went over there to train their installers on installing these 24 by 24 inch granite tiles. So if you look at this closely, at first you think you have quite a bit, but look at the trowel ridges there. You know, what was done correctly here is that you trowel in one direction, and when you trowel in one direction, it should be troweled parallel to the short side, because otherwise you can trap air in it, and you want to be able to get the air out. So in this case, you pull it up, and you got to add more thin set. Wherever you see the trowel ridges, that means that's a void, and that can be a problem. So on that last job, what should have been done? The architect should have specified either control joints in a particular layout that would have been consistent with the movement joints in the tile, and could have actually made it aesthetically pleasing in that regard. He should have, or he could have specified a non-bonded mortar bed where they put a cleavage membrane down and put a wire reinforced mortar bed on top. General contractors should have noticed that the layout of the control joints would be problematic, and before the installer ever got on the job, he should have been aware of it and either stopped the concrete guys from doing what they're doing or doing something different. And what should have the tile subcontractor have done? He should have sent out an RFI and waited for them to come back until they made the right decision. So when in doubt, you got to send out those RFIs. That's really critical in litigation. If you can show that you tried to point out to the architect, to the general contractor, what should have been done, that's important. So here I'm just going to give some photos showing you this is what we make the installers do on the jobs that we work on, and which every installer should do. Number one, you should be cleaning the backs of the tiles. There's always manufacturing residuals, whether it's a natural stone or a tile on the back, you should be washing it. The other thing is that you can't leave the back of the tile wet. We have another job we're doing on exterior veneer, and you can see where all the cuts were on this one return. All the tiles were debonding. And so what we're assuming happened is these guys had a wet saw cutting the tiles and putting it up there and weren't drying them off. The water will act as a bond breaker. This is another thing that we do, is you get your trowel, notch trowel, and you take the flat side of the trowel and you key it in, or we say burn it in, to the substrate. So the green there is actually a waterproof crack isolation membrane, so he's keying the thin set into it to make sure we have a good attachment. And we take that same flat side of the trowel and we key it into the back of the tile. That's how we make sure that we're getting great contact between the two key areas that we want to bond to. Next, we trowel so that all the trowel ridges are parallel to each other. And like I said before, you take the short side of, if it's a rectangle tile, you want to be parallel to the short side. One of the things that we do, in fact, on our online course, we show with glass that when you trowel irregular and set that glass in and beat it down, you have voids. You can't, air pockets that won't collapse. The whole idea of installing this way is that when you trowel that way, you shift it perpendicular to the trowel ridges so that the ridges collapse into the valleys. And with the glass, it really demonstrates how you get full contact with that. Here again, troweling not only on the back of the tile, but if you need the added thin set, you also trowel on the substrate. And of course, you want that to line up so that they're parallel to each other. You don't want to crisscross like I showed earlier. And then you want to shift that tile, again, perpendicular, collapse those ridges into the valleys. And then you pull it up and you should get something like this. Now this is pretty good. It's not quite perfect. If you notice that right corner there, you can still see a little trowel ridges, so you got to add a little bit of thin set. And this is real easy to do while it's fresh. So from a quality control point of view, we go around and we say, every area, we have guys, hey, pull that tile, let me see what it looks like. And it's real easy to do, and they can put it right back down. They just get their trowel, knock off what we call those little waves, fill in any gaps, and put it right back, and they can move right along. And the industry standards, ANSI A108 actually says that's what you as installers are supposed to do. So how can you limit installer errors? Quality assurance. You verified, just like you verify concrete slabs for moisture and contaminants, you verify thin set contact while it is fresh and that you can do something about it. And once it sets up, it's too late. It becomes expensive. Verify movement joints locations. I know a lot of you use subcontractors, but you should have a checklist so that you go out on those jobs at key stages of the job and say, before they start saying the tile, okay, where are you going to put your movement joints? You know, do you have the specification? If you don't have it, RFI, architect, where you want your movement joints. You know, figure this out in advance. Quality control. Quality control is a systematic approach to oversee the work performing the quality assurance testing. So you have to have a quality control plan. And on larger jobs, there should be a non-installing supervisor, somebody going around telling guys, don't do that, do this, orchestrating things. It makes it very productive. And what you're doing, you're creating a culture, a quality culture, because as everybody gets trained, the quality assurance and quality control ends up training. And what are you doing? You're creating, again, a culture of quality where they end up policing each other because everybody knows what each other is supposed to do. Plus, you're generating more skilled labor, and they're going to feel better about themselves, and they're going to provide better work. So, you know, quite often we hear, you know, well, you can't afford to do it right, but can you afford to have a problem? And actually having a plan and a protocol with supervision will actually increase your productivity. Every job we do quality control on, the subcontractor says, hey, that's going to cost us, it's going to slow us down, it's going to just be a problem. But it shows that when you have a plan and you have a program and a process, actually all those jobs end up being more productive because everybody's on their game, they know what they're doing, there's a systematic approach, and you think because you're having to pull a tile here or there, that's going to cost you, but it actually doesn't in the long run. It goes quite well. So, University of Ceramic Tile and Stone, we teach all these principles with our Tile Installer ThinSet Standards Verification course. It teaches all the current industry standards. It's taught both in English and Spanish. It teaches substrate inspection, preparation, ThinSet coverage, quality control steps. Teaches how to install shower pans, steam rooms. We have a very large section on gauge porcelain tiles, how to install it on floors and walls, and this is with animations and videos as well as the written word on there, and covers grouting. And this prevents problems and gives you credibility when you can say, my crews are all ITS verified. And Fuse is offering a special price at this conference that if you buy 3 tuitions for $100, you get 1 free, so it works out to $75 a piece. So Fuse is invested in these tuitions, and they've got quite a few left, so you should take advantage of them while they last. Thank you very much. Let us know if you have any questions.
Hey, Donato. Thank you, by the way. I wanted to say to the group on the tuitions for the ceramic tile and stone, which is an unbelievable course. For any of you here today, we have an in-house special. We'll let you have it for free. We'll give it to you for free. So anybody who wants to sign up, just let me or Don or Jerry know, and we'll get you set up. So now we'll open it up for questions. I know Donato likes that.
Yeah, that's a hard price to beat.
Well, it's a great course, so we really want to utilize it.
All right.
Yeah.
Questions from the audience? Here it comes, Kurt. Here comes the microphone.
It's probably mostly for George and Sim. We haven't probably been on a large project that actually has HVAC operable. Mm-hmm. We're always installing in temp-controlled environments.
Yes.
And we deploy data loggers to log temperatures, humidity, and dew point. And we typically do bond tests in that serviceable window. Mm-hmm. Can you comment on that? I mean, obviously, it's nearly impossible, especially our big bread and butter is healthcare, to ever get them to turn HVAC on due to contamination and things of that nature in the actual system itself. And so can you comment on temp conditions as long as they're serviceable?
Well, and I think that's the key. It is the The ASTM standards do not actually require HVAC operation. It does require service conditions. How it's achieved is irrelevant. There are lots of parts of the country that a lot of months of the year, indoor environment is the same as the outdoor environment. So I applaud your use of data loggers. I applaud your use of mechanisms to ensure that you have met the standard of service condition, but that's really what's critical. So,
It's not
and
required.
if other people aren't doing that, I know I've talked to quite a few. Data loggers are cheap. You put a couple on the job site, and I use it even for moisture testing.
Absolutely.
I'll put a data logger on, even if it's only for 24 hours, and be able to say, well, you were at service conditions, or, oh, by the way, you're not at service conditions. So,
Yeah. George was the only one on.
whoops.
HVAC is really not required, though. But you do have to hit service conditions, but how you do it, be careful of the propane fired salamanders and things like that, because they create, for every gallon of propane you burn, you put a good bit of moisture in the air, and that can impede your drying from some.
So F710 didn't it used to say operable HVAC? Or is it now just saying, I know it says a window, but.
Yeah, it's always had a window. I don't recall it ever requiring operational HVAC. I don't, I could be wrong.
You usually can't get a certificate until you get your CO. You can't turn it on, and you're going to be working before that happens most of the time. And and that's a real problem. But you've got to take whatever steps as you're doing to get to the service conditions window. It's basically usually about 65 plus or minus 10.
Right.
And was it 55 plus or minus 10 degrees, 10% on relative humidity? Right. If you get those, and that's where the thing is going to live, basically, or close enough. So.
And even that has parameters.
Yeah.
It's never going to be 50% relative humidity in Phoenix, Arizona. So, it is service condition, right?
Yep.
Pulling any excess moisture out of the concrete. So that's not true. As long as you maintain whatever the current temperature is.
Okay, so the movement of moisture out of concrete is based on vapor pressure differentials, and for every point of temperature and humidity, you have a different differential. So I will agree with you if what you're alluding to is that if we have a job site where because of ambient conditions and outdoor air that's moving through, it's 65% relative humidity, and then we turn on the HVAC and drop it to 30%, will that accelerate the drying of the concrete, otherwise known as pulling moisture out of the concrete? Yes. The answer is absolutely yes.
Yes.
If the concrete is at 90% and the air is at 60, we have a vapor or drive differential, and some moisture is moving out. If we drop the ambient relative humidity, we're going to accelerate the rate that moisture is being pulled out. Absolutely correct.
Yes. Yes, sir. Wait for the microphone.
Mostly for Sim, but when underlayment prices got really crazy, we started using LVT pad from Treadmore for glue down installations. Just kind of helped with acoustics as well as providing.
Sure.
Is that something that we should not be doing?
The Treadmore is a vulcanized SBR rubber, if that's what you're using. Now, no, it's not. If you're using Treadmore cushion, like 2580 or 2569, something like that, or.
No, there's a specific LVT. Yep. Yeah,
I think that's the one that's only about 1/8 of an inch thick. It's a little more forgiving than the crumb rubber is, although it is still a vulcanized SBR film. It is virgin. It has not been through God knows what. Okay, so it may be more serviceable, but you're still taking a little risk. You still have a basic chemical incompatibility between the phthalate-based plasticizers, terephthalates or orthophthalates, and SBR chemistries. All tires since World War II have been made with SBR chemistry. If you go to Goodyear, Goodrich, all the big rubber manufacturers, you look at their chemical compatibility charts, when you reach, and the plasticizer they have is DOP, dioctyl phthalate, which is very common, very basic typical plasticizer, and they are strong in saying unsuitable, do not use, do not get these two things together. So that's kind of what I based that on, is the hard science is done by the rubber manufacturers, and it's all SBR chemistry. SBR chemistry is also in multi-purpose adhesives. And everybody knows you can't put PVC back material down with a general purpose adhesive, because it basically slimes it. It basically turns it to kind of a goo, because the plasticizer comes out. It doesn't cause it to happen, but it can't withstand the attack of the plasticizer or the presence of the plasticizer, whereas the acrylics, the pressure-sensitive adhesives, can and maintain function, maintain their ability to do what they're supposed to do. But I'd think twice about it, and if you otherwise, get the name of the firstborn or something of whoever's guaranteeing this thing for you. Okay, so make sure you're covered. But I would counsel against it.
We've got 5 more minutes. If anybody has a question to ask.
I have one.
Okay.
Yesterday or Sunday, Ardex put a slide up with one of their new products, which was a roll-on moisture barrier that went up to 100%, one coat, not epoxy. We're seeing that more and more from manufacturers, I guess is the easy way out. What are your guys feeling on those products, compared to the traditional, two-part epoxy mitigation systems?
Okay.
Take a stab at that. No, I got my own opinions.
I can say from the ASTM standpoint, Committee F6 on Resilient, people have brought the concept of one-part sealers to committee, and they were so broad that it's not been written, probably won't be written for a long time. That said, if we go backwards and say, do moisture-cured polyurethanes have value? The answer is yes, and I think most of these are moisture-cured polyurethanes. So the film they create likely will meet the 0.1 perm, so I agree with that. My concern with some of them, and I haven't looked at all of them, is some of them are trying to promote the idea of minimal floor prep, and that's what scares me. Because if we have some kind of contaminant or the inability to bond sufficiently, then I'm concerned about losing that bond and failing the floor. So, when we look at F3010, which is all about the two-part epoxy, but it's also all about a minimum of CSP3, which you're only going to achieve with a bead blaster. So, there are those things. The other thing about 3010, and not many people do it, there's actually a requirement to do a mock-up and actually do a bond test of the film to the concrete. It's a D, I forget the number, I apologize, but you need to achieve a 250 PSI bond strength in that pull. So I would argue that if that one part can achieve a similar bond strength and be provable, then it likely will work from the standpoint that the one-part moisture-cured urethanes are pretty good products.
Yeah. Keith, a lot of people, the things you're seeing out there, like from Divergent Adhesives and some other people, are based on vanillidine dichloride, which is the chemistry for saran wrap. Anybody in here old enough to remember saran wrap? That's basically, they're using that, they combine that with a low molecular weight acrylate, butyl acrylate, and basically it has the viscosity basically of water. And they're saying that all you have to do is just grind the surface of the concrete, not a CSP3, probably a 1, maybe a 2 at most, and you put this on in 2 coats. The numbers look pretty good. What worries me is unless every single square millimeter of that concrete is in the same condition, it's a bit difficult. That's what the bead blasting does for you. It gets you to a good common denominator as far as the receptivity. And just because you meet the 1/10 of a perm, if it's not everywhere except one pinhole, that still can cause a problem. That's the beauty of the two-part things. They really take care of that. They still have that problem sometimes. But the vanillidine dichloride is coming. It seems to work. I've seen it in a couple places. You know, I'm badly from Missouri when it comes to that. You know, you got to show me not once, but a bunch of times, and it's got to work. But that's really, a lot of them are the moisture-cured polyurethanes, but that's what you're seeing, I think, from the people today. I work with the people who developed that a little bit, as did Lou, and it's, I don't know, it's one of those too good to be true kind of things, you know what I mean? It just seems like it's a little bit too simple, although the test, the E94 test, the permeability test clearly shows on a test coupon, which is not very big, that you do achieve the 1/10 of a perm. And if you do that, it meets that standard. But there is no standard for a one component that I'm aware of right now. So
I'm surprised to see Ardex put that out there. They're usually the Cadillac of systems. You know, understanding that the manufacturers are putting these high moisture adhesives out there that are, you know, just pushing more questions to us, you know, and trying to diverge us from doing the right thing. I mean, if they're putting that out there now, people are going to start to we don't use them.
I haven't looked at the Ardex thing closely enough to know if it is indeed the moisture-cured polyurethane or if it is the vanillidine dichloride that they're using as their basis. But is it two coats, 90 degrees?
No, one coat.
Just one coat.
They said one coat.
Well,
all.
I have not looked at that, and I suppose we ought to.
It is too?
Oh, it is 2 coats. Usually it's 1 coat this way and 1 coat this way with a paint roller. Yeah.
Yeah, there are some one coats out there, though.
Yeah.
So,
I thought they said 1 coat. I think Keith is right. They did, right? Yeah.
You have to use 2 coats, and on the bucket it says you get 1,500 square feet, and that is with the 2 coats. But he said you have to make sure you do 2 coats. That's what my local rep told me.
right. Yeah, so the only other concern that I'll express is even when I go back to some of the original epoxies, especially if this is very fluid, is achieving the mill thickness required to actually meet the E96 performance standard that they're claiming. So there are products that at 10 mils work pretty well, at 6 mils don't work so well. And again, I don't know enough. If you can meet the mill thickness required and achieve the bond, then it probably will work.
Okay, we are totally out of time. So thank you so much. I mean, it's usual. We're always out of time. Thanks, guys. That was great.